Okay, guys, lesson P7 is all about solving inequalities. Notice it talks about algebraic and graphically. Okay, so we did inequalities back in algebra, and in fact, my Algebra 2 kids already reviewed solving inequalities last week. Okay, so that means, all that put together means that this is really a review from Algebra 1, essentially. So, we are going to start by talking about solving absolute value inequalities. Okay, so if you have the absolute value of some quantity less than or greater than some number. Do you guys remember how I would talk about these absolute value inequalities? I don't know if you remember a whole lot of that or not, but I always talk about, is the sign a less than sign or a greater than sign? It was always kind of my trick for remembering this section. If we have the absolute value of some quantity is less than a number, okay, then first of all we need to remember that it is an and inequality. So it's going to be an intersection. It's and because, if you go back to the Algebra 2 notes, it says less than. And I always just kind of put the pronunciation on it to make you think less than. So anytime it's a less than sign, we're going to use an and. When you set it up, you will set up the given inequality, so u less than a, drop the inequality signs off, and remember when we set up the second one, there's not one, but there are two changes. Less than sign changes to greater than sign, and positive value changes to negative value. What's an and graph look like when we start shading this? It's in the middle. So usually the less than, it's in between the two numbers. Okay, the other alternative here, greater than. If it's a greater than sign, we're going to have the word or. So my trick when I teach algebra is I always said greater than, stressing the or part. Setup is no different. The only different with the setup is instead of putting the word and between them, you put the word or between them. The first one you set up as is. The second one, you change the inequality sign and the positive to negative sign. Okay, this one's a union. What's the shading look like on an or statement? Typically,
on the outside.
Typically goes out. And I am using the word typically usually because it's not all the time. Okay, so let's do an example of these. Obviously, basic algebra here. Okay, no graphs. We'll get to graphs here in a moment. Solving absolute value of x minus 4 less than 8. And I guess we should go back and review. When working with absolute value, what should always be your first question to yourself? Well, we'll ask and or, but before I do that, I don't know if anyone said it or not. Well, it's not even so much about positive or negative. I mean, I guess we could talk about, like, if it's equal to a negative, we can't do it, right? Okay. Is the absolute value by itself? Isolated? Isolated is the word I generally tend to use. But always check and make sure before you set up your two statements. Is your absolute value isolated? So in this case, is my absolute value by itself? Yeah, because I just have absolute value of x minus 4 by itself on the left. So, what are the two statements I set up? First statement is x minus 4 is less than 8. So the given. I need a word. What's my word? And. Since it's a less than sign, I'm going to use the word and. Second inequality. What's my second inequality? Okay, so you keep whatever's in the absolute value, don't change it. So x minus 4, less than becomes greater than, positive 8 becomes negative 8. And then you solve these, right? If it's x minus 4, we're going to add 4. I'm going to get x is less than 12 and add 4 on the other one, and x is greater than negative 4. Do you remember how to express a joint inequality that uses the word and? Okay. Okay, so yeah, this is the type where you put x in the middle. I tend to go with put the smaller number first, larger number last, and then if you do that, they're both less than signs. So I'll put negative 4 first, 12 last, and if you look, x less than 12, that sign just carries down, right? X less than 12. The negative 4 and x flip-flopped, and so my greater than sign flip-flops to a less than sign. In a compound inequality here, your signs always both face the same direction. So if I have my smaller number first, they're both less than signs, and then my larger number ends it.
We're gonna graph this.
Yes, we are. However, before I graph it, well, or we could do it after I graph it, I also want to talk about what does this answer look like in interval notation form. Would you prefer to graph it first?
Yeah, sure.
I don't know if it matters. We can do this either way, but okay. What does the graph of negative 4 less than x less than 12 look like?
It's just shaded up between negative 1 and 12.
Okay, it's less than 12, so it's less than 12, greater than negative 4.
Do we still need to do like half full circles and empty circles?
Don't think circles here.
Parentheses?
Think parentheses or brackets.
Wait, we do the full circles and empty circles.
Parentheses because there's no equal to.
Okay, so circles, whether it's a filled-in circle or an open circle, that still applies, but I'm trying to get you guys to know interval notation better. And pre-cal, we tend to use interval notation throughout. I'll be honest, in calculus, I see both sometimes, so, you know, it's not that the circles are completely going away, but I'm trying to get you guys trained on interval notation as well. So because these are not equal to, they're parentheses. And the parentheses open up with the shading in between them, right? So, speaking of, what is interval notation for this graph? Okay, my shading starts at negative 4, so I start there, comma, because negative 4 was not equal to, we use a parenthesis. Where does my shading end at? 12. So that's the other end of my interval, and with a parenthesis. Do be in that habit, I'm double checking myself as I speak. Yes, interval notation for all answers tonight. Everyone hear that?
Every answer.
Interval notation for all answers.
So,
Okay.
do you want us to write our final answer in interval notation or circle them?
It doesn't matter. I mean, I circled this one just because, you know, that kind of led us to here. But this is what my answer key will have. The interval notation and the graph
okay.
where expected. Okay. Example 2. 2 times absolute value of 3x minus 2 minus 3 greater than or equal to 7. What is step 1 here? Isolate the absolute value. Do not set up 2 right now. It won't work out well for you. If you go ahead and set up the 2 for you, it's not one of your answers that's going to be right. So, I'm going to work to get absolute value by itself. Add 3. So 2 times the absolute value of 3x minus 2 greater than or equal to 10. Is my absolute value by itself? Not yet. What do I need to do now? Divide both sides by 2. 2's cancel. Absolute value of 3x minus 2 greater than or equal to 5. Now, absolute value is isolated. So, now I'm ready for 2. The first one is always the original, the given. So 3x minus 2 greater than or equal to 5. What's my word? Or, because it's greater than or equal to, greater than. What's my second one? (3x minus 2) less than or equal to -5. We changed 2 things, inequality and the negative sign. Solve these, right? If it's 3x minus 2, I'm going to add 2. 3x greater than or equal to 7. I'm going to divide by 3. X greater than or equal to 7/3. Carry down your word. Or add 2 again. 3x less than or equal to -5 plus 2 is -3. Divide by 3. X is less than or equal to -1. Can I write my answer like I did the last answer with x in the middle? No. That only works with and statements. With or statements, if you were leaving your answer as an inequality, you stop there, okay? You can't put that together with an x in the middle. Let's look at what this graph looks like, and then we'll talk about interval notation. Okay. X greater than or equal to 7/3. How do I graph that?
Yeah,
7/3. What is that? 2 point something? Because 3 goes into 7 twice with a remainder of 1. So this is 2 1/3. My brain knows that is 2.3 repeating. I would like to think you guys are getting to the point where you know 1/3 is 0.3 repeating. But you can always do 7 divided by 3 on a calculator and get 2.3 repeating as well, right? But even if I know 2 1/3, I know that 7/3 is going to be in between 2 and 3 then. Okay. Greater than or equal to 7/3? We're going to do what here?
we're going to use brackets facing out.
Okay. We're going to use a bracket because it's equal to facing out because we are shading to the right where it is greater than or equal to. And then x less than or equal to -1. This time we're going left, and it's a bracket facing out that way. Okay, that is an appropriate graph. Now, interval notation. Question?
Since it goes out, wouldn't it be counter-infinite?
What do you mean?
Like, is it just like it would keep going like that?
It would be.
So for interval notation, when we write like
We need 2.
when we need to
Right. Yep. We're gonna have to have 2 separate sets of interval notation. We're gonna have an interval notation for this left piece of my graph,
Yeah.
and then we're gonna have an interval notation for the right piece of my graph. So if I start here, I like to start my graph left to right. What is the farthest thing left shaded? That's infinity, and that's negative infinity. So I'm going to start with a negative infinity. Infinities always use parentheses or brackets. Parentheses. So parenthesis, negative infinity, comma. Now, looking at this interval right here. It starts at negative infinity. Where does it end at? Negative 1.
That's a bracket.
Negative 1 with a bracket. Now, okay, this is an OR statement, yes? Which means it's called a union. And so official notation, instead of writing the word OR between these, would be to use what looks like a U. It's not like a U with a tail or anything. It's just a U. It's an official notation thing. Okay, so that's your official, what you use for the place of the word OR. Now, what about my second interval notation? Where does my shading begin? Okay, I'm going to use 7/3, but I'm not going to disagree with 2/3 or 2.3. It works. Now, I did it without asking, I think. 7/3 uses a bracket, right? We already have that. Comma. Where does my shading end? Positive infinity. And positive infinity uses a parenthesis.
You may not write U for that one.
The U was what goes in between the two interval
so
notations to tie them together. So there's only one U, and it's in between the two interval notations tying them together.
Okay.
Okay. I want to mention just a little bit about this next one. I realize we're about out of time. We're not going to get into it much. But the rest of this, we're going to be using our graphing calculators for. So it's going to be incredibly important or helpful to have your calculators, your graphing calculators with you tomorrow. So we're used to solving these by hand, right? Notice what it says here. A quadratic inequality is solved by first solving the quadratic equation. So in other words, making it equal 0 instead of an inequality symbol. So the first thing we're going to do is we're going to take this, make it equal 0. And then what we're going to look at is we're going to look and say, okay, we're going to talk about where this crosses the x-axis. And then we're going to talk about greater than. If we're looking for where a graph is greater than 0, where is that on a graph? Okay, where is our equation going to be greater than 0? And so greater than 0 means I'm going to be looking for where's my graph above the x-axis. If it said less than 0, we'll be looking for where's our graph below the x-axis. So, just kind of wanted to touch base about this. So, first thing, we'll talk about a couple different ways to do this. But x squared minus x minus 12 equals 0. So before we get into the actual inequality, how do you solve an equation that's equal to 0, that's a quadratic like that? Quadratic formula could be. This one actually factors. Okay? Not saying you couldn't quadratic formula, but So what's this one? If we factor this real quick, x squared is x and x, a product of negative 12, and a sum of negative 1. Minus 4 plus 3. What do you do to actually solve this then? Set them each equal to 0. So what we are finding right here are the x-intercepts. If you set each part equal to 0, we're finding that our x-intercepts are x equals 4 and x equals negative 3. What we've got to know now is my graph, where's my graph greater than 0 in relation to those? And that's what we will look at tomorrow. Okay?
So,
I won't do anything with homework until Wednesday. So you're welcome to start your homework if tonight's the night where you have time, but it won't be due till Wednesday. The only ones you can really do are the ones that are solving algebraically. Okay? Make sure you bring calculators with you tomorrow, please, for your own benefit.